Welcome to AP Daily. This is Mr. Burris, and today we're covering topic 2.8, tonicity and osmoregulation. So what will we be learning today? For today's lesson, we're going to look at graphing. What are the components of an effective graph? What are the different types of graphs? And when should graphs be used? So let's dive in. The components of an effective graph includes a title. The title should include experiment details and what is being measured. Secondly, there should be labeled axes with units. The independent variable should be located on the x-axis, and the dependent variable should be located on the y-axis. The third component is scaling. There should be uniform intervals. The scale should be large enough to analyze data, and the scale numbers need to be located on grid lines. Fourth, there needs to be identifiable lines or bars. So either have a legend or label each line or bar. And finally, when appropriate, there should be a trend line, which is a line of best fit that shows the general pattern or overall direction of the data. So for the types of graphs, first you have a line graph, which reveals trends or progress over time for multiple groups or treatments. It also tracks changes over time, concentrations, etc. The next graph is an XY graph, also known as a scatter plot. It is used to determine relationships between two different things. You can also compare two variables that may or may not have a linear relationship. The next type of graph is a histogram. It shows how values in a data set are distributed across evenly spaced or equal intervals. You can also explore the relationships between two or more variables with a histogram. For a bar graph, simply comparing multiple groups or treatments to each other. For a box and whisker plot, you're looking at showing the variability in a sample, and it is ideal for comparing distributions in relation to the mean. The dual Y graph is used to illustrate the relationships between two dependent variables. So let's practice. During practice, you're going to need to graph. So if you have some graphing paper, that would be helpful. The skill today, we're going to be looking at representing and describing data. So we're going to construct graphs, plots, or charts. So for the first practice, what I would like you to do is pause, read the question, analyze the table, and produce a graph. Once you've produced your graph, push play, and we'll go over it. Welcome back. You should have constructed an appropriately labeled graph to represent the data in Table 1, which is the number of drops of water placed on a penny. You should have produced a bar graph because you're comparing the average number of drops of pure water to the number of drops of soapy water. Let's move to the next practice problem. Again, pause your video, read the question, analyze the table, and construct your graph. Once your graph is complete, push play, and we'll go over it. Welcome back. You were supposed to construct an appropriately labeled graph to represent the data in Table 1, which represents percent change in mass of a potato core. For this graph, you should have produced a line graph. This line graph is interesting due to the fact that you have both positive and negative numbers on the y-axis, which causes 0 to be halfway up the axis. Also, on this graph, you could determine the molarity of the potato core by the point at which it crosses 0. That represents an isotonic environment, both inside the potato and in the beaker full of sucrose and water. So what should you take away today? First, the components of a graph include a title, correctly labeled axes with units, uniform intervals, identifiable lines or bars, and trend lines. The graph types used is based on the type of data collected. Graphs can be used to show trends over time, comparisons, distributions, correlations, variability in samples, and relationships between variables. Well, I hope today's video was helpful. Until next time, thank you.